Okay, so here we are in quiz number 5. Here's how this is going to work. They give me a table over here. This is a probability distribution over here. What they're talking about, X is the number in the group who say that they would feel comfortable in a self-driving vehicle. So you've probably heard those are in our future. Those are technology is producing self-driving vehicles. So you would just sit in the car and it would drive you around. Not everybody's comfortable with that. So what we're doing is we're basically asking a group of three people, and we're saying, hey, out of you 3 people, how many of you would feel comfortable in a self-driving vehicle? So X is the number and P is the probability. So in other words, if you ask a group of 3 people if they would feel comfortable in a self-driving vehicle, the chance that 0 out of the group of 3, maybe nobody in the group of 3 will be comfortable, what's the chance of that? Right there, 36%. 36.3, if you change that to a percentage, that'd be 36.3%. So that means 36% of all groups of 3 people, none of them feel comfortable in a self-driving vehicle. One person in the group of 3, that happens 44% of the time. 44% of the time, 44% of the groups of 3 people, 44% of the time that you ask a group of 3 people who, if they're comfortable in a self-driving vehicle, you'll get 1 out of the group. You'll get 2 people in the group that are comfortable 17% of the time, and you'll get 3 people, all 3, in the group that are comfortable in a self-driving vehicle only 2% of the time. So that's what that table means. That's what that table's talking about. If you ask a group of 3 people how many of them are comfortable in a self-driving vehicle, none of them will be comfortable 36% of the time, none of the group. 1 in the group will be comfortable 44% of the time. 2 out of the group will be comfortable 17% of the time. And all 3 in the group comfortable 2% of the time. Okay, so what do they want me to do with this? Does the table show a probability distribution? Yes, for sure. That's a probability distribution. It's showing how the different things that can happen, right? When you ask a group of 3, how many of you are comfortable in a self-driving vehicle, you're going to get either 0 people, 1 person, 2 people, or 3 people, and here's the various probabilities of those. That's called a probability distribution. It shows you how the probabilities are distributed, passed out in the group. Next, find the mean, and then it's going to say standard deviation. Well, how do we do this? We just simply do this thing on our calculator. So let me show you the steps. It's a TI 8384 calculator that we do this on. And the first thing is you got to put this data in L1 and put this data in L2. You hit Stat, hit the Stat button, and you're on the Edit menu, hit Enter, and then put the data in L1 and L2. And then once you got it in L1 and L2, then what you do is you hit Stat again and go over to the Calc menu and hit Enter. And you're on the you're on the one variable stats, and hit Enter on that. And it's going to ask you, now it depends on whether you have like an 83 or an 84 as far as what happens here. It's either you're going to put in, different ways you're going to do it, you're either going to put in L1, and how you get L1 on the screen, by the way, is you have to hit the second button, and then the 1 button. Second and 1, and that'll put an L1 on the screen, comma, and then second and 2, and that'll put L2. Here, let me just, you do that, and you do a comma, and what you'll see on the screen is L1, L2. That's on some of the calculators. Some of the newer calculators have you put the L1 and the L2 on separate lines. Somehow or other, if you have, mine is an older 84. I have an older 84. It's L1, L2, and here's how you get L1, second one. Here's how you get L2, second two, and I have to put a comma between them. But on some of the really nice new 84s, they actually ask you on separate lines to put in L1 and to put in L2. So put those in there. And then when you're done, you hit enter. When you're all done with that, hit enter. And then what you'll get on the screen is your answers. Basically, the X bar will be your mean. X bar means your average. And so what you should get for that one is, and I want you to round to one place, 0.9. And the standard deviation is the one that has the weird little, like an O thing with a little squiggle. That's a Greek S, stands for standard deviation. Anyway, you don't need to know that, but just know that that's the standard deviation. And that comes out to be 0.8 on your screen. So there we go. There's number 1. So what is that? That's the average. This 0.9 is the mean. It's the average, in other words. In other words, when you ask a group of 3 people, how many of you are comfortable in a self-driving vehicle, the average is 0.9, meaning just under 1. So the average is about 1 person, usually about 1 person out of the group, little less, 0.9, little less than 1, is comfortable in a self-driving vehicle. And this is the standard deviation. Remember what standard deviation means? Average distance from the middle. So whatever the average is, 0.9, not everybody's average. Some are above, some are below. How far are they from the middle typically? 0.8. That's the average distance from the middle. So and in the group of 3, on average you'll have 0.9, just under 1 person who's comfortable with a self-driving vehicle, but that's spread out, an average distance from the middle of 0.8. So there is some spread there. All right, here we are in number 2. Okay, so they're asking about the accompanying table that describes the number of adults in a group, of 5, who reported sleepwalking. So they asked a group of 5 people, how many of you sleepwalk? And here's what they said. So the number that sleepwalk, nobody in the group of 5, that happens 18% of the time. 1 person in the group of 5, that happens just under 40% of the time. 2 people in the group sleepwalk 24% of the time. 3 people in the group are sleepwalkers about 14% of the time. 4 people out of 5 in the group are sleepwalkers 2.5% of the time. And all 5 are sleepwalkers in the group of 5 only. What is that? That's 0.4, right? Because you move the decimal 2 places. 0.4% of the time. So that's a binomial probability distribution. It's binomial in the sense, bi means 2, right? Like a bicycle has 2 tires. Binomial because there's 2 states. You either sleepwalk, or you do not sleepwalk. So whenever you're asking a question that just has 2 answers, yes, no, sleepwalk, don't sleepwalk, as opposed to like, what's your favorite, ask a group of 5 people, what's your favorite color? They could have blue, orange, green, lots of, not just 2 options, right? So if you're asking a 2-option question, sleepwalk or don't sleepwalk, that's called binomial, 2 states, 2 answers. And here's the probabilities for it. So there's 2 answers, but there's 5 people in the group, right? So nobody could be a sleepwalker 18% of the time. 1 person in the group is a sleepwalker 40% of the time, etc. All right, so what's their question? Find the probability of getting exactly 4 sleepwalkers out of the 5 adults. Exactly 4? It's just right there. It's this number. 0.025. 0.025. We just read it off the table. That's exactly 4. Now it says 4 or more. 4 or more. So that means 4 or 5, right? If you're asking 5 people and you're wanting to get 4 or more, that's 4 or 5. Can't get more than 5. So that would be these two together, wouldn't it? So that's going to be, what, 0.025 and 0.004. Wasn't that what it was? Yeah, 0.04025. 025. Add that up. 0.029. So that's the chance of 4 or 5. This is the chance of exactly 4. So exactly 4, 4 or 5. Okay, now here comes their next question. It says, which probability is relevant for determining whether 4 is a significantly high number of sleepwalkers among 5? Well, whenever you ask the question, hey, is that a really high number? Is that a really high number? If somebody wanted to figure out what's the probability of getting a 90% or better on exam number 2, we would say exactly that which I just said, 90% or better. Nobody would say, what's the chance of getting exactly 90%? I don't want 91. I don't want 92 or 93 or 94, 95, 96, 97, 98, 99, or 100 even. I just want exactly 90. You know, that's silly. Nobody would do that, right? They would say, hey, I want to get 90 or better. I want to get an A. What's the probability of that? So that's the kind of thing we always ask. What's the chance of getting an A, 90% or better? Nobody wants exactly. So what is relevant to see if 4 is a high number? It's 4 or 5. See what I'm saying? You always ask that or better. Nobody does exactly. It's not the exactly one. So if somebody would say, hey, is that you ask the group of 5 people, how many of you are sleepwalkers? Is getting 4 people a really high number? They don't mean exactly. When somebody talks that way, they say, hey, yeah, what's the chance you're going to get 4 people? They mean 4 or more, 4 or 5. So that's what they would really mean, and that's down here on part C. Since probably 5 sleepwalkers includes getting 4 sleepwalkers, the result from part B is relevant. The result from part B is relevant, meaning this is our number, not the answer from part A. So if somebody says, is 4 a significantly high number? If I said, hey, I have a group of 5 friends, and I asked them, how many of you are sleepwalkers? And it was 4 people. Is that a significantly high number? We mean, is the chance of getting 4 or more, 4 or 5, is that a pretty low probability? Is that a rare event, like the chance of winning the lottery or something? It's or getting struck by lightning. Is that surprising that if you have a group of 5 friends or 5 family members and you ask them how many of you guys are sleepwalkers, and you say, I got 4 people out of 5. Is that high? We mean, is getting 4 or more a significantly high number? So what we mean is the chance, is the probability of getting 4 or more low. That's what they're asking down here. Is 4 a significantly high number? Why or why not? Well, the probability of 4 or more, 4 or 5, right? If you're getting 4 or more sleepwalkers out of a group of 5, you're getting 4 or 5. If the chance is 0.029, that's less than 0.05, right? Because that's a 2.9% chance, which is lower than a 5% chance, right? Because you always move the decimal 2 places when you change to percentage. So 2.9, kind of messing this number up, is less than 5%, or 0.029 is less than 0.05, same thing. And so that's the significance level. Whenever something has a less than 5% chance, we say it's significant, it's surprising. That's how the world usually, business, government, science, medicine, if anything is less than a 5% chance of happening, we tend to think it didn't just happen by luck. That's a significant event. We call that significant. Like we believe something real is happening there, something serious. So if there's less than a 5% chance of luck. So did the probability come out less than 5%? Yes, 0.029 is less than 0.05. So is that if you asked if you asked a group of 5 friends and 4 of them were sleepwalkers, is that a surprising result? Yeah. According to our table, that's only going to happen 2.9% of the time that you're going to have 4 out of 5 people be sleepwalkers. That's rare. That's less than 5% of the time. So that's a significantly high number. So we say down here, D, yes, since it's less than 5%, it's significantly high. We don't choose this option because that says greater than 0.05. No, we want less than 0.05. There we go. Okay, here we are on number 3, a gambling problem. So you're going to pick 3 lottery game. You pay $1.44. You pick 3 digits, such as 211. If you select this, where am I? The same sequence as the winning number, the ones that are drawn out of the hat or out of the bucket or whatever, then you win and win $3.99.39. All right, first off, how many different selections are possible? So if you're going to pick 3 digits, how many of them there are going to be? It goes from 000, 001, 002, to 999. How many are there? From here to here is 999, and this is 1 more. So there's 1,000 different numbers, right, that are possible. 1 through 999, and then the 000, that makes 1,000 different possible selections. So there's 1,000 different 3-digit numbers, basically. These are all 3-digit numbers. There's 1,000 different 3-digit numbers. So then what's the chance of winning? Well, 1 in 1,000, right? There's 1,000 different 3-digit numbers, and you've got to pick just the right combinations. 1 in 1,000, divide that in your calculator, 0.001, they want a decimal. And then if you win, what is your net profit? Now, we might just say, too quickly and wrongly, well, you win $3.99, $3.99.39, right? That's what they said. You win and collect $3.99.39. But careful. They said net profit. Remember, you got to take what you win minus what it cost you to play. You did pay some money, $1.44. You still had to pay the $1.44 to play the game. If you subtract those in your calculator, you get $397.95. $397.95. That's really going to be your net gain, your net profit, right? Because you had to pay the $1.44 just to play the game. You win, they pay you $399.39. So your bank account actually went up by $397.95. It's your net profit. Okay, find the expected value. Now, that's the most important part of this problem. What is expected value? Expected is another word for average. Average value. So in gambling, it's also the same in insurance policies. There's an average thing that's going to happen. Meaning that, this is random. You're just randomly playing a game and picking 3 numbers. You can get lucky or not lucky or whatever. It's true. And a bunch of people can play the game, and some will win and some will lose. Randomness. But there is still an average randomness that we can figure out. And that's exactly what casinos do. They know exactly what the average is, the expected value. That's exactly how they know how much to set the bets and the payoffs and everything, because they can figure out that on average they're still going to win. Even though some people will win, some will lose, the overall average will be in favor of the casino. Same thing with insurance policies, life insurance, car insurance. They set the average, right? Because sometimes you collect on an insurance policy, you have an accident. Sometimes you just pay the insurance company forever and don't collect. It's kind of like gambling. It's very similar, really. And so they calculate, insurance companies, just like casinos, calculate expected value. That's what their mathematicians do all the time. The average thing that's going to happen monetarily. So anyway, so how do we do it? Our calculator will give us the number. Basically what we do is here, let me go to a fresh screen here. And what we're going to need to do for expected value, let me write it up here for you. Expected value. In fact, let me put back the answers we already had. 1,000, 0.001, and 397.95. Okay, so to figure out expected value, what you do is you have to put in L1 and L2, like we've learned how to put data. Stat. Got to hit the stat button on your calculator. Edit, enter, get L1, L2. And put in L1, basically, the amount, the two cases. You can win or you can lose. Right? If you win, how much money are you going to win? So you put the dollars for winning and the probability of winning. And then the dollars for losing. So yeah, let me just get this out of the way. And the probability of losing. So that's what you put in. So in our particular case, the dollars you're going to win, if you win, that's this. Put 397.95. And what's the probability you're going to win? Right there. 0.001. And what's the dollars you're going to lose if you lose? You'll lose the $1.44. Just the money you paid to play the game, you'll just lose your $1.44. Oh, I'm sorry. And that's got to be, I should have said, you got to make that negative. Negative. Because it's losing, right? So it's a negative effect on your bank account, whereas the winning is a positive. You don't need to put a plus sign; it automatically is positive, the 397.95. But I'm just emphasizing the win is positive to your bank account. The lose is negative. It'll subtract $1.44 from your bank account. What's the probability of losing? Well, if the probability of winning is 0.001, then the probability of losing equals 1 minus the probability of winning, right? Like if the chance of rain today is 20%, then the chance it won't rain is 80%. You subtract from 1, which is the same as 100%. So it's going to be 1 minus 0.001, so lose equals that. So lose equals 0.999. It's very likely you're going to lose. A 99.9% chance of losing, only a 0.1% chance of winning. So you put those numbers in your calculator, and then you hit Stat, and go over to Calc, and hit, and then on one variable, you hit Enter, and then you got to put in L1, L2, or you might put L1 and L2 on separate lines. And hit Enter. And then X bar will be your expected value because it's an average. Remember, X bar is the mean or the average. That'll be your expected value. And so when you do that for this problem, you get minus 1.04. It says round and there's hundredths 2 places. So what does that mean? That's dollars, right? So that means that you can expect, and the casino can expect, on average, that everybody who plays this game is going to lose $1.04. Now you think, no, wait a minute. How could they lose $1.04? They're either going to lose the game and lose $1.44, or they're going to win and win a bunch of money, $397.95. Yes, true. There's no way to lose exactly $1.04 on one play of the game, but this is the average. This, there'll be one winner and a bunch of losers, and the average will come out. On average, it's like every single person that played the game lost $1.04. In reality, everybody lost a little more than that, and one person won a whole bunch. But all the casino cares about, or the insurance company, is what's going to happen on average, because that's what's going to matter to them. That's how their bank account is going to be affected. So every person's going to lose $1.04 is how they see it, the insurance company or the casino. They know what's going to happen on average. So if everybody loses $1.04 and like 1,000 people play the game, right? Every person losing $1.04 times 1,000 people, move that decimal 3 places, the people are gonna lose $1,040. The casino will gain $1,040. That's why casinos that advertise winning and stuff like that are just bald-faced lying. It's like a cigarette company advertising better health if you smoke. That's just a bald-faced lie, and I just don't appreciate their lying to all of us. I would be okay with casino industry if they would not bald-faced lie. If they would just say, hey, come to the casino, you'll have a fun time, it'll be entertaining. That's like the cigarette company trying to act like smoking is cool. All right, if they want to say that, whatever. I'm not going to raise an issue. It's not a bald-faced lie. But if the cigarette industry started saying smoke more, it'll improve your health, there would be an outrage in society, because that's clearly a bald-faced lie. We know it's the opposite of the truth. All the data shows it. Well, it's the same way with casinos and gambling, that it's a bald-faced lie to say you're going to win. Now, do some people win? Of course, but they know very well these averages. They know they're going to win overall on average, and if you play long enough, you will be part of this average and lose money. It's for sure. It will happen, and they know it. And so they shouldn't act like you win. It's a lie. It's a bald-faced lie. Just like you don't die from your first cigarette, but it builds up over time. In the same way, gambling, you will lose money. I'm not saying gambling's wrong for everybody or anything like that. Gamble if you want to. Know, though, that you're going to lose money on average. Don't get fooled. Because the people that get in trouble, that lose their houses and things like that, are people that really think they're going to win. If you're going to a casino, you're going to lose money on average. It's going to catch up with you. And if that's your entertainment, that's okay. Just know that. I lose money going to movies. And I probably spent tons of money on movies over the years. But that's okay. Dinner's out as well. That's entertainment for me. So, and if this casino thing is your entertainment, great. Just know you're going to lose money. Don't be fooled by their lies. You will lose money, but if that's worth it to you, that's fine. Just don't get fooled and think you're going to win. That's when you get in trouble. All right, so down here they go, blah, blah, blah. You have a bet. Thanks for entertaining my spiel there. Coming on down here, if you bet $1.44, some game, expected value minus 1.04. Well, that's the same as expected value we got here. So they're saying this is some other game, pick 4 or whatever. Expected value is the same. So which bet is better? Neither, because they have the same expected value. So that's the point of that question. All that matters in the end, in a random situation, gambling, insurance, whatever, is the average or the expected value. If two different games have the same expected value, then you're going to have the same average loss on those games. That's the point. Okay, we're on number 4 now. Assume that when adults with smartphones are randomly selected, 46% use them in meetings or classes. So 46% of cell phone users, smartphones, people that have adults with smartphones, use them in meetings or classes. If 8 adult smartphone users are randomly selected, find the chance that exactly 4 of them use their smartphones in meetings or classes. Okay, so what are we doing here? This is a binomial distribution. Why? Because there's two cases. You either use your phone in the meetings or in class, or you do not use your phone, right? There's only 2 cases. There's not your favorite color with 10 different options. It's either use the cell phone or you don't use the cell phone. That's binomial. And there's 46% of people use them in meetings and classes. About half. Okay, so what they asked me, what's the probability that exactly 4 out of 8, right? We asked 8 people. We're going to come up to a group of 8. We're still doing this group thing. Come up to a group of 8. And we asked them, how many of you use your cell phone in class or meetings? We're wondering, what's the probability that exactly 4 out of a random group of 8 will be cell phone users that use their cell phone in class and in meetings? So how do we do that? Well, we're going to use the binomial probability tables on your calculator. So let me show you where that is. Let me go to a fresh screen here. So it's in your calculator. You got to hit second on your TI. This is on the TI. Second, and distribution, D-I-S-T-R. It's above the V-A-R-S key. It is the VARS key. It's just the blue writing right above the key. So that's it's up near the arrows. So right up near the arrow buttons. Right up near the arrow buttons, you'll find a VARS button. And right up here it says distribution. So right there, hit that second distribution, and when you do, you're getting the different distributions the calculator can handle, the probability distributions. Roll way, way, way down. It's down like on number, what is it? A. It's, at least on my calculator. It's all the way down to letter A. It says Binomial PDF. Binomial PDF. So that means binomial probability distribution function or something. So this is binomial, all right? Hit that, hit enter. And depending on, calculators are a little different. The different versions of the TI calculator a little different. On mine, you have to, you've got, it just gives you a parenthesis, and you've got to put in the number of trials, the probability each time, and then the exact number you want. So for Binomial PDF, that's what you got to do. So in this case, we have how many trials? We have Binomial PDF, and we have 8 trials, meaning 8 is the number, right? 8 different people are being tried, meaning we're asking them, do you use your cell phone in meetings and classes? 8, we're trying that out 8 times, asking 8 different people, 8 trials, 8 different people, do you use your cell phone in meetings and classes? The probability for each person each time is 46%. That's why, because that's, you got to change it to decimal point, 46, because that's what they said. They said 46% of all people use their cell phone in meetings and classes. So every time you ask a person, there's a 46% chance that they are a user of cell phones in class and meetings. And what exact number do we want? We want exactly 4. We want to see if we can get exactly 4 out of 8, out of our group of 8. So just put that in, hit enter, and you'll get an answer. They want 4 decimal places. I got 0.2665 on my calculator. So make sure you can get that answer. We'll go to number 5. Okay, so here's number 5. Now it's very similar to number 4. Down here in number 5 now, it says, okay, 48% use their cell phones. It was 46 up here. It's almost the same. We're asking 8 adults. What the probability that at least, notice it says at least 6. At least 6. Okay, so it's similar to number 4, but a little different. The main difference, instead of saying exactly 4, it says at least and then 6. So, all right, so how do you do that different kind? Well, I'm going to flash over here. Here is the notes. Let me cross out this number 3, doesn't matter. This is the notes from exam to notes. This is on the Canvas course. So here's the notes. You can find it for the online students. You can find it on the Canvas course. It's exam to notes. So these are the notes I give before every exam to help you with problems. So here I am walking through all the steps. You can put this on your note card for the test. So, all right, how does it work? Well, first off, how do you identify it? If you've got a probability exactly, less than, at least, more than, etc. So there's ours, at least. How do you do it? Well, for exactly, that's the one we just did. You do Binomial PDF. There it is, trials, probability, and 4 for exactly 4. We just did that. That was this problem, exactly 4, right? Now we're doing at least 4. Well, it's 6, but same thing. At least 6. How do you do at least? Well, it's going to be binom CDF, notice, not PDF. All these are CDF, CDF, CDF. So you only do PDF for exactly. All the other cases, like at least, more than, at most, less than, anything other than exactly, you do CDF, binom CDF, binom CDF, binom CDF. It's only for the exactly case that you do binom PDF. All right, so let's do it. What does it say here? It's very similar. It's number of trials, probability, but then it's that number or less. Notice it's always that number or less, that number or less, that number or less. That's what you do for C. It stands for cumulative distribution. Remember, to accumulate means to build up to that point. So if they've accumulated up to 3, then we're talking about 3 or less. They've built up to 3 or built up to 4. Right? That's what that means. It's cumulative. It's not just one exact case, not just 3, but all the accumulation up to 3, 0, 1, 2, and 3. Everything up to 3, 3 or less. That's what CDF means. So in our case then, we're going to need to do binom CDF. And remember how it works here. Let me write it. It's number of trials, probability, and number or less. That's what CDF has. Whereas up here on number 4, the previous one, that was binom PDF, and that's very similar. Number of trials, probability, and then number exact. Right? All right. So how are we going to do this then? So we're going to go binom CDF. What's our number of trials? Well, 8. We're asking 8 people, a group of 8. Every one of the 8 people is going to answer whether they use their smartphone in meetings and classes or not. What's the probability for each person? It's 48%. That's the number they gave us. They're saying 48% of the population uses their cell phone in classes and meetings. Now, we want number or less. But wait a minute. That's not right, is it? I mean, they're saying here at least 6. Let's be clear on this. What does at least 6 mean? If I said, hey, I've got at least 6 coins in my pocket, what does that mean? I've got 6 or 7 or 8 or more, doesn't it? Isn't that what at least 6 means? 6 or more? Right? So that's not number or less, is it? That's the opposite. Exactly. So what is the opposite of at least 6? What's the opposite of at least 6? What's the opposite of 6, 7, 8? It'd be 0, 1, 2, 3, 4, or 5, meaning 5 or less. Isn't that the opposite of 6 or more? Right? At least 6, 6 or more. The opposite is 5 or less. 5 or less. It's the opposite. So therefore, we've got to do opposite here. When they want you to find at least 6, you've got to put 5 here, because that means 5 or less. But that answer is going to be the opposite. You think, what are you doing, Mr. Aaron? 5 or less, that's the opposite of at least 6, right? So I take one. So once I hit enter, and I get my answer, then let me come down here and write. Then take 1 minus, and then do you know where the answer button is on your calculator? Hit second ANS, which is the lower right-hand corner. It's above the negative button, very bottom row. In the bottom right corner, just right next to the enter key, because it grabs the last answer. So take 1 minus, because when you do opposite, like if there's like an 80% chance of rain, or I'll make it a decimal because we're talking decimals. If there's a 0.80% chance of rain, then 1 minus, there's a 0.20% chance it won't rain. The opposite, right? So at least 6 is the opposite of 5 or less. So when I get the answer here for 5 or less, I got to take 1 minus, that's a big scribbly minus sign, 1 minus the answer and hit enter. And you'll get the real answer for number 5, 0.1198. There it is. Now that's what these instructions are saying. I'm writing it all out here for you super clearly. You can have this for yourself. Get the notes, on the Canvas course for the online students. If for at least 4 or at least 6, just put 6 in there. It means 4, 5, or more. So the opposite is that. So instead of 3 or less, it's 5 or less, right? Because 4. The opposite of 6 is 5 or less. And then we need opposite, so 1 minus answer. That's giving you the steps there. So there we go. All right, finally, number 6. When purchasing bulk orders of batteries, toy manufacturer acceptance, here's their plan for acceptance. So it's another one of these things where they survey for quality control. So they randomly select and test 44 batteries. That's a really important number. And determine whether each is within specifications. The entire shipment is accepted if at most 3 batteries don't meet the specifications. In other words, at most 3 bad batteries, 3 or less. A shipment contains 6,000 batteries and 3% of them do not meet specifications. They're bad. What is the probability that this whole shipment will be accepted? Probability the whole shipment will be accepted. Okay, let's think about that. This is where statistics gets into a lot of words. Reading and understanding words becomes very important in statistics. So the probability that the whole shipment will be accepted. What is it? Well, let's write that out. Probability whole shipment accepted. What's got to happen for the whole shipment to be accepted? It's accepted if at most 3 batteries are bad. So they're really saying, what's the probability 3 or less bad batteries, right? If it's 3 or less that are bad, then you accept the shipment. Okay, so this is another one of them binom, and it's going to be a CDF, right? Remember the table back here? If you're doing at most 4, this was an at most, isn't it? At most 3, same thing. At most 3 or 3 or less, same thing. So when you're doing an at most, that means you're going to do binom CDF. So here we go. So the only time you do binom PDF is for exactly. All right, so remember what it is. Number of trials, probability, and number or less. So it's going to be binom CDF. Number of trials. How many are we trying? How many batteries are we testing? Is it 6,000? No, don't be fooled by that number. We don't need that 6,000 at all. That's just how many batteries in the shipment. Remember, they randomly select and test 44. We're testing 44. That's how many trials. What's the probability? What's the chance each time that a battery's going to be bad? Well, 3% of them do not meet specifications. There's 3% of the batteries are bad. Each battery we test, there's a 3% chance it'll be bad. And what number or less do we want? 3 or less. Hit the buttons on your calculator, and what you'll get is 0.9575, rounded to 4 places. And then it wants you to change that to a percentage. You know how that works, right? You move the decimal 2 places. 95.75% of the shipments will reject. So they'll accept that percentage of the shipments, and they'll reject what percentage. So they're saying that's the opposite, right? If you accept or reject, that's like rain and no rain. So if they're going to accept 95.75% of the shipments, what percent will they reject? Well, it's going to be 100% minus 95.75%, which is 4.25% of the shipments. They're only going to reject 4.25% of the shipments. So almost all of the shipments will be accepted. So with this plan, with this way of inspecting, where they just grab 44 batteries, test them, and if they get three, at most three, right, three or less bad batteries, then that's good. If they get more than three, they go, no, this must be a bad batch. Not going to ship it. But if they get three or less, they assume the batch is good and they ship the whole thing. And so if you have a batch with 3% bad batteries, 95% of the time it'll get through. It'll be shipped. 4% of the time it'll be held back. There we go.